Okay, so first I want to add a few items to our discussion of streams and glaciers. And in the hydrology section, we talked about the concept of a drainage basin. And this is the Mississippi River Drainage Basin. If you recall, we kind of displayed how many streams flow into that. And that can be divided into smaller ones, and those can be divided into smaller ones still. And the drainage basin is made up of a network of streams. And so if you recall, streams are the general term that we call things like rivers or creeks or whatever else. We call them all streams. And the way we differentiate them is by what we call their order. So these small streams meet up to make bigger streams, and those bigger streams get together to make larger ones still, and so on. So the very first ones in the network are called first order streams. And when two streams of the same number get together, they make the number goes up. So if two number ones get together, they make a number 2. Now, if they're not the same number, it doesn't change. So while this number 2 and number 1, they get together, it remains at level 2. It's not until a 2 and a 2 meet up that it goes up to level 3, and not until a 3 and a 3 meet up that it goes up to level 4. So as streams of the same order meet up with each other, the number increases. And so you have a whole bunch of these first order streams, and then fewer and fewer of the higher order streams. So if you take this example watershed here, this one has 16 first order streams and only 5 second order, only 2 third order, and only 1 fourth order. So by default, the first order streams, there's always going to be more. Those are most of the. There are always going to be more of them than any of the other orders. So wanted to point that out. And a little bit more on glacial erosion and glacial deposition. So glaciers erode by what's called plucking and abrasion. That the ice will actually freeze over rock and kind of incorporate that into the glacier, kind of plucking it off the ground. And we can compare that to other types of erosion with water. What we call stream erosion is called fluvial erosion. And fluvial erosion works through hydraulic action. That's where the water itself is flowing and moving material. And then also abrasion, as the material in the stream knocks around in the stream bed. That's a very powerful erosive agent. The same goes with wind. The act of the wind itself moving the material is called deflation, just dislodging by the wind itself. But then it's abrasive. It's kind of like a sandblaster, because the sand and material in the wind, it kind of works through abrasion as well. So with glaciers, so we can you should be able to recognize these terms. So fluvial means stream erosion, and it works through hydraulic action and abrasion. They all have abrasion. Aeolian is wind erosion, and it works through deflation. So deflation is associated with aeolian or wind erosion. And then glaciers work through plucking. Plucking is the type of erosion done by glaciers. And then what they all have in common is all three of them have abrasion of one sort or the other. And while we have erosion and then we have deposition. So the stuff that's deposited by glaciers is called drift. These are materials that are moved by glaciers. And compared to the type of material left behind by streams and especially wind, they're very large pieces of material. So they're pieces of all kinds of different sizes, because the glacier is so powerful, it can move very, very large pieces of material as well as smaller ones. In fact, what you also have are the very largest pieces of drift called glacial erratics. These are large boulders that get left behind because they've been brought to a place by a glacier, and then the glacier melts and leaves behind a large rock that's not like any of the rocks that are in that place. So look at this rock here. How did they get there? At one time or another, this was during the ice ages, a big glacier kind of dragged it out there, and then the glacier melted and left the rock behind. And it's what we call a non-local rock. It means that the rock isn't like the rocks of this place. If you if you watch the the film about Yosemite Valley, the formation, when they showed that dam that they found, they noted that the rocks were of different types of rock from different places. It had all been pushed to a single location by a glacier. So here's an erratic, kind of out in the middle of nowhere. This rock got left behind back during the ice ages sometime. And another thing that glaciers do is they push they kind of work like a bulldozer, and they push up a amount of material called a moraine. And the glacier can melt away and leave the moraine behind. So again, in the Yosemite film that we saw, there was sort of a dam that had formed to create that lake that was in Yosemite Valley. That dam was created by a moraine of all this material that had been pushed up by the glacier. All right, so let's compare also deposition. We have fluvial or stream deposition. That leaves behind material that's called alluvium. Alluvium is the stream deposits, all the sand, silt, and clay that a stream leaves behind, rock even. Also another related term, this is called pluvial. So while fluvial has to do with streams, pluvial has to do with lakes. So for example, what they found in Yosemite Valley, the reason why it was flat bottom is because it's full of pluvial deposition. It's full of lake deposits because it got blocked up by that moraine, formed a huge lake, and then all the deposits from the lake settled and made the valley flat. Now with wind, you have a couple of things. We have sand dunes. Those are sand deposits, easy enough. And then you have loess. Loess is another name for silt deposits, deposits of silt. Silt is finer, dustier material, kind of like talcum powder. Then lastly, glacial deposition includes drift, just the unsorted material, including erratics. And then it also pushes moraines in its path as well. So these are different examples of deposition by different kinds of what we call geomorphic agents, streams, wind, and glaciers. Another thing that glaciers do is they polish rock. So hopefully you saw that in the video, that some of the evidence for glaciation in Yosemite Valley includes that you can see where glaciers have moved over and you see kind of a stripes. That's caused by rocks grinding over it, and also a polished look to the rock. In some places where you have an outcrop of rock material, if you look at these grooves in the rock, that's caused by material in the glacier, rocks embedded in the glacier, scraping over it as the glacier passed. And then lastly, the concept of periglacial environments. These are really essentially tundra environments. These are places that are really cold but not covered in ice. While they're not covered in ice, they have permafrost. And permafrost means that the ground is frozen at least part of the year. So sometimes in the past, these have been covered in glaciers, but maybe they're not now. These are largely tundra environments at high latitudes near the poles, and also at high elevations as well, like high in the Sierra Nevada.